Alright, and this is the first lesson in the Logarithms chapter. And a logarithm, really what it is just an inverse of an exponential. And the relationship is as follows. So if you have an exponential equation in the form a to the b is going to be equal to c, where a is the base, b is the power, and c is the product or the answer, this can be written as, in logarithmic form, it's going to be equal to log of base a of c is going to be equal to b, where a is the base, c is the product or the answer, and b is the exponent. And this is very equivalent as a to the b is going to be equal to c. It's the exact same, but it's in logarithmic form. And the reason why we do this is that so that we can solve these exponential equations for b without having to do guess and check. So one of the first examples we're going to do today, it's basically writing these exponential equations in logarithmic format. So let's get started. So remember, a is our base, so base is going to be 2 here. So this is going to be equal to log the base of 2, and then c is our product, which is going to be 16, and that's going to be equal to the base, or the power, which is b, and the power in this case is 4. Again, if we want to go back to it, we'd say 2 to the 4 is going to produce 16 as an answer, which is the same as this exponential equation. Doing the next one, base of 3, so log of 3, and the product is 1 over 81, is going to produce negative 4, which is the power. As you can see, it's pretty simple. So again, doing this one again, base 8, so we're going to choose base 8 here. The 64 goes here. And the b, which is this top value, is going to be 2, and that's going to be positive 2. Again, 8 squared is equal to 64. This one, 9 over 3 can be simplified as 3, but log base 8 of 512 is going to be equal to 3, or which is equivalent to 9/3, but 9/3 is 3. So 8 cubed, again, is 512. It's just an equivalent expression. So that's the basic converting exponential equations into logarithmic format, and that's just the basic rundown there. So now so what can we actually do with log? So let's go the other way around in this time. So going the other way around, let's do log of 3, 9 is going to be equal to 2. So we want to convert that into exponential form. So it would be the exact reverse of what we were doing before. So this can be written as 3 squared is going to be equal to 9. So that's going to be equal to 3 squared is equal to 9. And these are equivalent expressions. Let's do another one. Log base of 25 of 125 is equal to 1.5. Converting that into exponential form, that's going to be equal to 25 to the 1.5 is going to be equal to 125. Alright, let's do some more. How about we do log base of 5 to the 0.04, and that's going to be equal to negative 2. Writing that into exponential form, it's going to be 5 to the negative 2 is going to be equal to 0.04. Alright, so now you may be asking, what's the point of doing this? What's the point of converting it into exponential notation, logarithmic notation? Well, the reason is to allow us to solve exponential equations, but that's going to come a little bit farther on. So before, we need to do some solving equations here. Alright, so let's do some equations where you have to use logs. So how about log base 2 of 8, and suppose they want us to evaluate that. So this is equal to x, and here we have to solve for x. So the way we're going to interpret this equation, this can be written as 2 to the x is going to be equal to 8. And using our common knowledge, we know that x is going to be equal to 3 because 2 cubed is equal to 8. But as you'll see later on, there's actually an algebraic way to solve for this without having to know that in fact it is 3. So there's a way coming up on that later on in the next video, but so that's how you do it for now. Alright, so here's another kind of next self-explanatory one. Log base a of a is going to be equal to x. So what might this be? So we can convert this into exponential form again, and that's going to be a to what power, let's say some power y, is going to be equal to a. So that's basically saying a to what power is going to get you a. That's basically what it's saying. A to what power is going to get you a to the 1. So obviously, x, sorry, it's supposed to be a to the x, because this can be written as a to the x is going to be equal to a. So a to the x is going to be equal to a to the 1. So therefore, assuming that these are equal, x has to be equal to 1, because if a to the x is equal to a to the 1, which means x is 1. So that's how you convert that. So that's kind of self-explanatory. A to the power of 1 is going to get you a to the 1. Alright, so now, another thing about logs is that we're going to, instead of always writing down the base, which can get very tiring over time, what we like to do as mathematicians, we like to assume stuff. So we created a common logarithm, so as to speak. So when we see a log without a base, we're going to assume it's base 10. So assume you see an equation that's written like this. We're going to assume it's going to be base 10. So now this is basically asking 10 to what power, so what this is basically asking is going to be 10 to what power is going to give you 1000. Again, using our common knowledge, we know that x is going to be equal to 3 here. Alright, so that's pretty much it for writing logarithmic equations. We can do some more examples. How about convert this. Okay, how about this? Find this answer without using a calculator. So log 4/16 is equal to x. So what we're going to do, we're going to use the same method as we did before. We're going to convert that, so that's basically saying 4 to the x is going to give us 16. Well, 16 as we know it is equal to 4 squared, therefore x has to be equal to 2. Alrighty, so this is basically just a basic general overview, just a very basic brief introduction to what a log really is, and how we're going to be using that in the future is going to be many complex uses, and that's basically the basic definition of a logarithm, how you're going to convert exponential equations into logs, and next video is going to cover lots of the properties about logarithms, and those will help us to solve complex exponential equations. Thank you for watching.